Bismillahirrahmanirrahim. Today we will cover the fifth part of our lecture, chapter 7, that is steering system. First, the basic slide of our course, the powertrain or the power flow of a conventional rear wheel drive vehicle. In first part, I will give a quick recap of all the four parts which we have covered of this steering chapter, and then we will proceed with the lecture of today's. First, we have the engine where the power developed, then we goes to the flywheel and clutch, then gearbox, transmission, and propeller shaft, differential box, and then distributed to right and left wheel. Then we have the light systems, the brake, the suspension, and the steering, which is our topic of today's. So first, a quick recap. Four parts which we have covered previously. Now, the steering system. Steering system, the major parts of steering system is steering wheel, steering column, steering gear, steering linkage, and this is how it's look like. Now, steering wheel, the steering wheel which consists of a rigid rim and number of spokes connecting the rim to a center hub attaches to the top of the steering shaft at its center. So basically it's your driving wheel. Now, the steering wheel also includes the airbag made of a nylon cloth covered with a neoprene, and it is basically inflated with the help of an inflator module, and the nitrogen gas is filled in this airbox, and deployment time is 30 to 65 milliseconds. Once deployed, the airbag cannot be reused. So a lot of electrical circuits is there. So it is how it's look like. And I have told you your safety bag or the airbag will only work when you are having a seat belt on. If you are having a seat belt on, then it will not work. Then we have a steering column. Steering column is the second part, which here it is connected with your steering wheel. Then we have the steering shaft along with its column, the U joints, and it attached to the steering gearbox. So detailed view of the steering column. The components of the steering column is steering shaft, universal joint, flexible coupling, column cover, collapsible column, tilt mechanism, and telescopic steering column. So these are the major parts of the steering column. Now this is the flexible coupling, which is attached to the steering gear input shaft. Now the third part is the steering gears. A conventional steering gear uses steering gear assembly that moves linkages and sports arm to the steer the vehicle. So it's depend on different types. We have the sector gear is a pitman shaft, also known as sector shaft. Let's see. This is the conventional steering gear mechanism in which we have a pitman shaft here, the steering gear, the pit sector gear, and it is connected with the worm gear shaft. Now, steering gear ratio. So when the steering wheel is turned, the front wheel turns on the steering axis. If the steering wheel is rotated 20 degree and results in the front wheel rotating in a 1 degree, then the steering gear ratio is 20:1. The front wheel usually are able to rotate through 60 to 80 degrees of rotation. The steering wheel therefore has to rotate 20 times the 60 to 80 of that number of degree. So the variable ratio we can also achieve with the help of this tooths of this very worm pitman shaft gears. So and the other case we have in which we have a rack and pinion steering gear system in which we have this steering gear input shaft. It is a pinion attached here and it's move along the back and forth on the rack assembly. So this is the detailed view of the rack and pinion steering gear assembly. The last part is the steering linkages. After the gearbox, the steering linkages relay the steering forces from the steering gears to the front wheels. Most conventional steering gear linkages uses the parallelogram type design. The parallelogram is a geometric box shape where the opposite sides are parallel and equal. So the center links, we may have different names like shown here. So this is like this. You have pitman arm with coming from the gearbox. Then we have this center link, and this from this center link we have the inner tie rods end, and then goes to the outer tie rods end. And this is the idler arm which is attached on the passenger side to balance this all the steering linkages. Now, in second part, we have covered the steering system analysis, rack and pinion linkages, steering box, gearbox, and truck steering system. The steering system analysis, we have discussed the directional response behavior and steer the front wheel in response, how it works. Then we have discussed the steering system analysis, the Ackermann geometry, and the trapezoid. Instead of parallelogram, we have trapezoid geometry. And then we have to, if while turning the inner wheel, on which side we are turning has to turn more as compared to the outer wheel, which is has to turn at less angle. So this is the formula which we have studied. Now, the other part, which is the wheel alignment principle. We do wheel alignment in case of wear of a steering and suspension components, bent or damaged steering suspension parts, sagging springs which can change the ride height of the vehicle and therefore the alignment angles. So first alignment related problem, first was the pull, and your vehicle is pulling on one side. Then lead or drift, this is the mild pull, the second alignment problem. Then the road crown effect. The roads are not flat and they are crowned from the center. So this problem has to be catered for. And then vendor. Vendor is the condition when constant steering wheel correction are necessary to maintain straight high direction on a straight level road. And second last is the stiff steering or a slow return to the center. Then last is the tramp or shimmy vibration. So these are the alignment related problems which we face in a vehicle. Then there are few angles which we have to cater for in your steering geometry, that is the camber, caster, and toe in. Now, if you are viewing the vehicle from the front or the rear, the inward or outward tilt of the wheels from true vertical as viewed from the front or the rear of the vehicle. Then we have talked about the zero camber, the positive camber, and the negative camber. If it is tilt outward, then it is positive camber. If it is tilt inward, then it is negative camber. If it is aligned with the true vertical axis, the wheel axis, then it is a zero camber. Same goes here. Then we have caster, the second angle. Caster is the forward or rearward tilt of the steering axis in reference to the vertical line as viewed from the side of the vehicle. Camber was from the front or the rear of the vehicle we see. Now caster is from the side angle, sidewise. So we have discussed about the zero caster, the negative caster, and the positive caster. And the best example for the caster angle is your front wheel of the bicycle. Then if the caster angle is more, then we have to use the steering damper. And this is the steering damper which we used if we have the more caster angle, and it is used in different vehicles. And the third angle is the toe angle. Toe is the difference in between the front and the rear of the tires. Toe is most important of the alignment angle as viewed from the top. So now we are viewing from the top. So they are exactly parallel. So this is zero toe. If the inner distance of it is more and this distance is, if inner distance is more and this distance is less, then we call it toe out. If this distance, the front distance from the tire is less and this distance is more, then we call it toe in. As like this, this is the positive toe or toe in. And if this is the case, this is the negative toe or the toe out. Now the total toe is defined like this. Then the effect of toe on the tires. Then there are few other angles which we have to cater for while doing the steering system analysis or steering system alignments. The steering axis inclination. Basically, the steering axis inclination of the vertical reference line and the steering suspension system angle. So this angle is your steering axis inclination, or it is also known as SCI or kingpin inclination. So it depends upon the suspension which you are using. Now, included angle is the sum of the steering axis inclination plus the camber angle. So that is your included angle, and scrub is the distance. Positive scrub if we have a positive axis inclination plus chamber and the steering axis inclination and the vertical reference line, we have a distance. That is your positive scrub angle. And if we have this type of intersection, then we have a negative scrub angle. Then turning radius toe out or toe on turns. We have talked about this. Turning radius, setback, thrust angle, tracking, four-wheel alignments. Then we talked about the front steer versus the rear steer and what will be the effect having when we have a front steer and rear steer, the understeer effect and the oversteer effect. Then quadra-steer, in which all the four wheels are independent and they are having their own angles with the help of this electronic gadgetry. Then we talked about the three killer bees. If we have any problem in your suspension or steering, the bend broken or binding components, then we have to go for the alignment. So this was the homework which I have given last time. Now, coming towards the last part, and which is today's topic, that steering geometry, how it is affecting on the wheel and what are the errors which we are there in the steering geometry errors. So let's see first, this is figure. This is your wheel, this is your spindle, the steering knuckle, this is the upper control arm and lower control arm, and this is the relay linkages. And this plus sign is the ideal center of the steering arm ball travel. Okay, and this is steering arm ball travel, this relay linkage here. So in a typical steering system, the relay linkage transfers the steering action from the gearbox on the body of the vehicle to the steering arm on the wheel here. Steering arm over here, all the movement from the steering gear coming to this point. The steering action is achieved by translational displacement of the relay linkage in the presence of an arbitrary suspension motion. There is obvious potential for steering action to arise from suspension motion, which are known as steering geometry errors. For an ideal steering system, the relay linkage is designed such that the arc described by its ball connection to the steering arm exactly follows the arc of the steering arm during suspension and deflection. I read again. In the typical steering system, the relay linkages transfer the steering action from the gearbox on the body of a vehicle to the steering arm on the wheels. The steering action is achieved by translational displacement of the relay linkage in the presence of the arbitrary suspension motions. There is obvious potential for the steering action to arise from suspension motions, which are known as steering geometry errors. For an ideal steering system, the relay linkage, this one, is designed such that the arc described by its ball connection here and here of the steering arm exactly follows the arc of the steering arm during the suspension deflection. Now, the second error is the toe change. Well, this is your wheel, spindle, knuckle, upper control arm, lower control arm, relay linkages, the steering arm ball joint, and this plus is moved here, ideal center for the steering arm ball toe travel, geometry error causing toe change. When the left wheel moves into the either jounce or rebound, the end of the relay linkage follows an arc which pulls the steering arms to the right as viewed in the figure. This produces a left-hand steer when the linkage is located behind the wheel center. So when we have this toe change, when the left wheel moves into the either jounce or rebound, the end of the relay linkage follows an arc which pulls the steering arms to the right as viewed this pulls to the right. This produces a left-hand steer when the linkage is located behind the wheel center. Now the third is the roll steer. So we have this wheel, the steering neck, spindle, knuckle, upper control arm, lower control arm, relay linkages, the steering arm ball joint, and the plus sign is here, the ideal center for the steering arm ball travel. For the cases where the linkage is located off of the wheel, the arc followed by the relay linkage and will produce a left-hand steer on the wheel as it goes into jounce and right-hand steer when it goes into rebound. So for the cases where the linkage is located aft of the wheel, the arc followed by the relay linkage and will produce a left-hand steer on the wheel as it goes into jounce and the right-hand steer when it goes into rebound. Steer in the opposite direction will be produced on the right side of the wheel. So steering geometry error or to add under steer. Thus toe in and toe out will occur with each cycle of bouncing when the vehicle travels down the road. Because of the symmetry of this case, both wheels will steer in the same direction when the body rolls. For example, in a turn on the right, the body rolls to the left, inducing jounce on the left wheel and rebound on the right. For example, in a turn to the right, the body rolls to the left, inducing jounce on the left wheel and rebound on the right. Thus, both wheels steer to the left out of the turn, adding an understeer effect to the vehicle directional response. So they will add an understeer effect to the vehicle directional response stability. Now, steering forces and moments. So this is your field. Forces in forces in x, y, and z direction and moments in x, y, and z direction. The forces and moments imposed on the steering system emanates from those generated at the tire's road interface. At this point of contact, the forces and the moments are originated. The forces are measured at the center of the contact with the ground and provides a convenient base by which to analyze the steering reaction. So by the help of this, we can analyze the steering reactions. Now front wheel geometry has to be taken for. This is your wheel, the steering knuckle, the kingpin axis, the caster angle, the center of the tire contact, the kingpin inclination, kingpin offset at the ground, the steering rotation geometry at the road wheel. The important element of the steering system consists not only of the visible linkages just described, but also the geometry associated with the steering rotation axis at the road wheel. So the important elements of the steering system consist not only of the visible linkages just described, but also the steering geometry associated with the steer rotation axis at the road wheel. This geometry determines the force and moment reactions in the steering system, affects its overall performance. So this geometry determines the force and moment reactions in the steering system affecting its overall performance. The steering angle is achieved by rotation of the wheel about a steer rotation axis. Historically, the axis has the name kingpin axis and the range of 0 to 5 degrees for the truck and 0 to 15 degrees on the passenger car. So this is the range in which we have this kingpin axis inclination. Front wheel geometry. Now on the other angles, the lateral offsets curve adds fields of the road and reduce static steering efforts by allowing the tire to roll round an arc when it is turned. So lateral offsets curve adds fields of the road and reduce static steering efforts by allowing the tires to roll around an arc when it is turned. Caster angle results when the steer rotation axis is inclined in the longitudinal plane. Caster angle normally ranges from 0 to 5 degree and may vary with suspension deflection. If we have caster angle more than 11 degree, then we have to use the steering damper. We have studied previously. Now, steering system forces and moment, we have studied this slide on when we were studying the wheel, the tires. So this is your wheel. Now, this is your wheel plane. And in this direction, it is moving the direction of wheel heading. The tractor force is Fx, but the direction of wheel travel is this. The angle is here alpha, that is the positive slip angle. Now in y direction, we have lateral forces by Fy, and we have the rolling resistance My. The wheel torque is there, and overturning moment Mx. Now in vertical direction, we have the normal forces Fz, and gamma is the positive inclination angle, and this lining torque Mz. And we have studied this when we were studying the tires. The ground reaction on the tire and are described by three forces and moments. On the front wheel drive cars, an additional moment is imposed by the drive torque. So we have three forces, three moments, and then we have a additional moment imposed by the drive torque. We have normal forces, which is in the direction of the Z direction. Then we have attractive forces in the direction of rotation, X moving, X lateral forces in the Y direction. Then we have the aligning torque, Mz rolling resistance in My, and overturning moment in X direction. So we have this terminology and axis system, the wheel plane, the wheel center is here, the center of tire of contact, the loaded radius, the longitudinal force, the Fx, the lateral force, the Fy, the normal force, the Fz, overturning moment Mx, rolling resistance moment My, and aligning torque or aligning moment Mz, slip angle, the angle alpha in the direction of wheel heading and direction of wheel travel. That is your slip angle. Or and then we have a camber angle or the positive, this which is in the vertical plane. So this reaction in the steering system is described by the moments produced on the steer axis, which must be resisted to control the wheel steer angle. Ultimately, the sum of the moments from the left and right wheels acting through the steering linkages with their associated ratios and efficiencies account for the steering wheel's torque feedback to the driver. So with this, we comes to the end of our chapter 7, that is the steering system. So up till now, we have covered the seventh chapter, that is the steering system. Thank you very much.